Okay, welcome back. This is the second day of review of the study guide. Today we're going to be doing page 4, 5, 6, and 7. Last few pages of this thing. Okay, so it says, label the box from the periodic table. Well, the 12 at the top of the box of the periodic table is the atomic number, and that tells us the number of protons in the nucleus. The two big letters, one or two big letters, the first one always capital, is the element symbol. This is the actual name of the element. And this down here is the average atomic mass. It says drag and drop for 26 and 27. What are the properties of metals? Metals are ductile. That means they can be pulled out into wire. They're malleable, which means that they can be bended and pounded into shape. We said they have a certain amount of hardness, like iron is really hard and gold is soft. Metals are shiny. They're all good conductors of heat and electricity. And metals, most of them, are solid at room temperature. The non-metals, the not metals, were exactly the opposite. They are not malleable. They are not ductile. They are often brittle, which means they break because they don't bend and you can't pound them flat into shape like them being malleable. They are not shiny. They are dull. They are the exact opposite. They're poor conductors of heat and electricity. And most of them, when we look at the periodic table, all the way over there on the right-hand side, nitrogen, oxygen, fluorine, chlorine, and all the noble gases, most of them are in the gas state at room temperature. Polar means that the atom, the compound, has a pole. It has a positive in or negative in. So there's something that's making it out of balance. Okay? And covalent means that they're sharing electrons. So if it's out of balance, it must not be equal. So it's unequal sharing of electrons. Nonpolar means no poles. It's perfectly in balance. There's not a positive in or a negative in. So this is a result of equal sharing. The force that holds atoms together in a compound is called a chemical bond. Lightning is an example. It is not a solid. It is not a liquid. It is not a gas. It's a high charged state of energy. It is plasma. Law of conservation, all the laws of conservation of mass, whether conservation of mass, energy, whatever, they all say that nothing is created or destroyed, lost or gained. Which of these substances can't be broken down into another by ordinary chemical or physical means? We can break molecules apart with chemical processing. We can separate mixtures by physical means. We cannot separate elements, and we can separate acids. This is just a compound. Okay, let's take a look at this next page. Review. Okay, two or more substances that are physically combined do not make an element. They do not make a compound. That would be chemically combined. They make a mixture. Dalton believed that atoms of the same element are the same. Remember, we said it sounds kind of silly now, but time it was a big deal. Atoms of each element have a unique mass. That's what's at the bottom of each box on the periodic table. Atoms of different elements were different. Different elements can combine to form compounds. Compounds could be broken apart and put back into separate elements. Like when we watch the decomposition of water. Label the periodic table. Well, the first column is the alkali metals. The second column was the alkali earth metals. In the middle here were the transition metals. And along the staircase are the metalloids. And over here, all the way to the right, are the nonmetals. So let's look. Well, 1 is pointing to the transition metals, things here in the middle. 2 is pointing to the metalloids. 3 is pointing to the nonmetals. Okay. Group 1 will form bonds with group 1 plus 7 equals 8. They have a full outer energy level of 8 electrons. Atoms that become charged by gaining or losing electrons are called ions. And a group of atoms where there was more than one is called poly, which means more than one, like a polygon has more, multiple shapes. A polynomial has more than one nomial, and they're polyatomic. They have more than one atom. Okay? We drop glass on the floor and it breaks. So the shape of the glass has changed. The properties of the fragments remain the same. There's no new substance when you break a glass. You just have a bunch of little pieces of glass. This is an example of a physical change. Something actually happened, but it didn't make a new substance. Okay, the step of the scientific method that's the educated best guess or prediction of what will happen is the first thing we do is state a problem as a question. Then we may do some research. And then we make a hypothesis of what we think will happen. After the hypothesis, we do an experiment where we gather data and we make a conclusion. If you know these facts about an element, it has 10 protons. It's a gas, it has 10 protons, and it's used in light. Which of these facts is the most valuable helping you identify an element? There are a lot of gases. There is only one element that has 10 protons. Its atomic number would be 10. And it's used in lights. Well, there could be a lot of gases used in lights. So the one that's most important is the one that says that's who it is. It's 10 protons. It has an atomic number of 10. From this information, we look at the periodic table and we see that neon has an atomic number of 10. Particle theory of matter, which is the kinetic theory, it was unit 2, states that matter is made up of tiny, well, it says particle theory, so it's made up of tiny particles that are in constant random motion. The particles are moving around, and the speed of their motion depends on the temperature. Oh, I have a capital S there. See the one thing ion. Okay. All right. Halogens are in family 7. And they need 1 electron to get to 8, become stable. When a bond forms and electrons are shared, it is co, which means sharing, valence, sharing valence electrons. When electrons are transferred, it is an ionic bond. Now look at the pie chart. What element is most common in a human? Well, it's this biggest part over here. It's the oxygen. The least common in a human is, it's the smallest piece of the pie right here, 7%, so it's other. How much hydrogen is in a human? Well, let's look here. 10%. That's right. Okay. Label is a mixture, element, or a compound. Salt water is a mixture. It's a mixture of salt water. Air is a mixture of a bunch of different gases. There's oxygen, CO2 you're exhaling. Okay, the atmosphere is mostly nitrogen, so you know there's at least 3 gases. Oxygen, which has a symbol, is an element. Table salt, which has a formula, is a compound. Okay. Chris is trying to break a record for blowing the biggest balloon. Chris is going to test different brands of balloon. Chris makes sure all the balloons are blown up with air that's the same temperature. Chris compares all the balloons to his standard brand from Family Dollar. The independent variable, that's the thing that Chris can change. Okay, so Chris is going to test different brands. He can change that. He's going to make sure they're all blown with the same temperature. He's not changing that, so it's not a variable. And he compares them all to the standard brand. So the brand of the balloon is the independent variable. That's what Chris is changing. What does he think might depend on which brand he uses is how big it'll blow up, the size. The temperature of the balloon is not the independent variable because it says he's keeping them all the same. It's not the dependent variable because it's not a variable at all. They're all the same. It is not the control. It's not what he's comparing it to. It is a constant because it stays the same. The standard brand is the control because he compares all of the balloons to the standard brand. Okay. Circle the picture of the student who is positioned correctly to read the graduated cylinder. Well, it wouldn't be this guy looking down into it. It wouldn't be this guy looking past the top of it. It wouldn't be this guy looking down at an angle. You should look straight at it. So this is the one that you should pick. Okay. On this last page, reaction that absorbs energy. If something absorbs, it's going in. Like when a sponge absorbs water, the water goes in. So we're looking for the one that says in. This says endothermic. So what's going in, and what's going in is the thermal energy. Because the energy is going in and away from everything around it, it's going to feel cold. The reaction that releases energy and lets it out, okay, is exiting. Just like when you exit the building, you go out. Release. And it will feel hot. And using this information, we're going to look at these two. Okay, the wood burning is an example of, well, it feels hot. The energy is coming out, so it must be exothermic. When you mix aluminum fluoride with water, the reaction feels cold. We said the one that feels cold will be endothermic. Okay. What is the volume of the liquid in the graduated cylinder? We read at the bottom of the meniscus, so it's 30. We read at this lowest part of the hoop. Okay. Density is defined as mass per unit of volume. The reason why I put this in here is this is the way a lot of the questions on a test will be written. They'll give you this and say density is defined as mass per unit of volume. And from that, you're supposed to be able to figure out what the formula is. Well, per means this, it's got to be some kind of mathematical operation. It doesn't mean you add mass plus volume. It doesn't mean you subtract the mass from the volume. It doesn't mean you multiply the mass from the volume. You divide. Now, if you've got this part, then you know that the formula for density is mass, per means divide, by volume. So it's mass divided by volume. The triangle. So we have density. What's on top, because it's divided by, is mass. And then this fraction bar is mass over volume. That's mass divided by volume. So now if we fill in the numbers and they're up and down, we divide the top by the bottom. If they're next to each other, we would multiply. If the liquid in the graduated cylinder has a mass of 60 grams, so 60 would go up here on the top. We said the volume was 30 down here. So 60 divided by 30 is 2. And our unit is going to be grams divided by milliliters. So what is the unit? It's grams divided by milliliters. So sometimes you put a slash there, it would be G/ml. Okay. Put these elements in order from the least to the most. Acetane, bromine, fluorine, chlorine, and iodine. The INE tells us they're all in family 7. So I'm going to look on the periodic table at family 7, which is halogens. I'm going to go to the top, and at the very top, the one with the smallest atomic mass will be fluorine. Right under fluorine is chlorine. So I'm just going down the column. And then right under chlorine is bromine. And right under bromine is iodine. And right under iodine, the last one is the acetane. And you should fill this study guide out yourself in live worksheets. Check anything you got wrong. You can look at this video, these 2 days of review that I gave you, and then you'll be taking the benchmark. And believe me, if you filled out this study guide and you study what you got wrong, you will do very well on the benchmark. You have nothing to worry about. Hope you're having a great day, and we'll see you next time.